All right, today we're gonna do about rounding and ordering. Okay, so I'm sure you all remember your rounding. Like let's say if we have, let me change this pen. I want to use a highlighter. Let's say if we have this one, okay, 1586. Okay, so if you want to round it to the nearest tenth, what do you think we should put to the nearest tenth? Okay, so we will have 1590. Why we use 9? Because 6 will round up, right? Okay, if it's above 5, it will round up. So same thing, similarly, if we want to go to the hundreds, it'll be 1600. Why is 16? Because of the 8. So we have to see the next one. Okay, so next one we will have 7798. Now this one, if you round it to the nearest 10, 8 to 8 add to 9 become 10, right? So 10 we have to continue to add. So you get 7800, 7800. Okay, both also will be 7800. It's okay, it's fine. It is already memang the nearest 10. All right. Then when we look at number 3, okay, 928. All right. So if it's to the nearest 10 will be 930. And what about if it's to the nearest 100? It will be 900. This time the 9 does not increase. Why? Because 2 is less than 5. Okay. So similarly, when we look at here, if we see 3, so means 2, 3, 6. Oops. 650. Where else to the nearest 100 will be 23700. So please remember the key point here is the 5. If it's 5 and above, then the number in front will increase by 1. But if it's 5 and it's 4 and below, then the number will just remain the same. It will just be rounded off. Okay, so this is all the rounding you can have. All right. Now, but this is the one that you have already learned. By right, you should have learned in primary school already. What? Okay. But now, when we talk about decimal, it's actually the same thing. Okay. It's just that the difference now. All right. Let's say we have 6.752. Okay. If you want to round it to one decimal point, where is the one decimal point? It is over here. Okay. So that means we took a look at the 5 and then we change it. So since it's 5, right? So it's 5. So we have to round up, become 6.8. If it's 2 decimal points, where is the second decimal? First decimal, second decimal. So we took a look at here. Now it's 2. So 2 is above 5 or below 5? Below 5. So it remains the same. You retain as 6.75. Okay. All right, so I'm just going to quickly go through this. Okay, you can try it on your own. You see, you can quick math faster than me or not. Okay, so 10.615. All right, if I round this to one decimal, since it's over here, okay, 1, so that means it retains, so 10.6. Now, but what if oops, what if it's two decimal? We put kite over here, so we get 10.62. Okay, so this one 3.7, 3.70. Okay, so in this case, although normally in maths we won't write the zero anymore. Okay, but when it's mentioned to round it to two decimal place, we still want to see two decimal place there. Even if it's a zero, you just put it there. Okay, so here will be get 18.4, and then next one will be 18.41. Here will be 98.7 because 2. Okay, well here will be 98.73. All right, 98.73. Now, what about cases like this? Okay, if it's one decimal point, we just leave it as 43.0. Okay, remember, 0 must exist there. Okay, because we round it to one decimal place. What about two decimal place? This one easier lah because we see 8. All right, 8 become 43.01. Okay, so 100.08 for one decimal place will be 100.1, and then 100.08, 7.5. 7.45, 23.7, 23.75. Okay, 13.9. All right, and then lastly is 13.87. Okay, okay, this one I'll give you 3 seconds to think. 2.3. Another 3 seconds. 2.32. Okay, all right. So this one I will post it up for you all to try it out. I mean, actually, yeah, I'll just post this slide for you to try yourself. Okay, if you are curious to find out the answer, you can always check with your teacher. All right. Now, so what's the point of doing all this rounding? What's the point? Why must we do it? So 麻烦, right? But actually there is a use for it. Okay, this is especially useful for quick math. Okay, why? Because we can use it to help us estimate the answer. For example, 3.99 times 4.8. If I call you to calculate this out, you're going to be headache, right? So what do? I just change it to 4 times 5. Okay, there we get 20. So the actual answer won't be 20, will definitely not be 20, but it will be very close to 20. Okay, so let's try to estimate these answers. Okay, I'll give you all 5 seconds for each part, then I'll review the answer. Okay, ready? Let's see who can quick math faster. 1, 2, 3, 4, 5. So 7 times 4, 28. Oops. Yeah. Okay. Then this one. 1, 2, 3. 3 times 10. 30. Wait. Wait. Oh, it goes that way. Oops. Should be 13 times 2. No. This one is wrong. Oh no, I made a mistake. Okay, it should be 13 times 2 equals to 28. Just want to check whether you know or not. That's why. Okay, 7 times 9, we get 63. Okay, 4 times 9, we get 36. 6 times 6, 36 also. Okay, 3 times 3, 9. Oops, I think I go a bit too fast. You all should try to quick map the last 3. Okay, 5, 4, 3, 2, 1. 9 times 5, 45. 5, 4, 3, 2, 1. 7 times 8. What's 7 times 8? 56. Okay, 8 times 7, also 56. All right, so this is the reason for rounding. Okay, all right. Next, we're gonna talk about place value. Okay, it's a lot, but the today I know we are going through a lot of things, but today is easy topics, so you all should be able to handle it. Okay, so place value. What is a place value? I'm sure you have some rough idea, or rather some distant memory of this. Okay, it's basically the value of the position of the digit whereby it gives the value of it. So the further left, the greater the value. So for example, if I have this super long number 98765433321, okay, so we have to take a note at where is the decimal point first. Okay, and then this is the unit. So this is on its own, is not is alone already. It's just 3 units. Okay, 4 tenths, right? Because there's 4 of the tenths. All right, 3 is just 3 only. 3 on its own. 3 apples. But if one box of apples contain 10 apples, then we have 4 of those boxes, so we have 40 apples, right? Hundreds, same idea. Okay, thousands, tens of thousands, hundreds of thousands, millions. Okay, so far all these, I'm pretty sure you all should be very familiar with all this already. Okay, now if we are going the opposite direction, take a look, is the units. To the left will be tenths, right? To the right, it will be the tenth. Notice the THS. Okay, the THS, that one means is the 3/10. Okay, means it's only like if I take an apple, I cut into 10 pieces, 3 of those pieces is here. Okay, so 100. This one, if I'm like a master chef, I cut into 100 slices. I only have 2 slices. This one is the 2. And then I use some super powerful micro, I don't know what cutter. I only have 1000. Okay, so this one means if I cut the apple to 1000 pieces, 1000. Take a look. That is the THS. Okay, now this one is all you have. You are pretty familiar with. Okay, so we have 700, 1000, 80, and so on and so forth. Okay, you can take a look at this on your own later. The slides will be uploaded anyway. Okay, you can try it out yourself as well. Okay, so why am I telling you all this? Okay, remember here, this one is bigger and bigger and bigger and bigger, right? You go to bigger, 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 right? But in this case, it's actually going smaller and smaller. So why is this important is that when we start to order the decimal. So if we want to put the decimals in the order of highest to lowest, means we need to know which one is the biggest. So first we need to take a look at 1, 3, 5, and 0. Okay, we look at the tenth first. Okay, so which one is the biggest? 1, 3, 5, or 0? Obviously is 5. All right. So nah, I don't use this method. Well, okay lah. You can try use this method also lah. Okay, what they do is that you make them all the same amount of digit. Here got 3 digits, right? 3 digits after decimal. So here got 2 only, so we add a 0. Here only got 1, so we add 0, 0. And yeah, if you find my method confusing, you can use this method as well. Okay, so 0.120, 0.302, 0.500, and 0.060. So that way you can see, if you just look from the right to the left, okay, you can see which one is the biggest. Okay, so 500, 302, blah blah blah. Okay, very simple. So if I want to put all this from the lowest to the highest, so how? This one I need to change it into 0 because all 3 digits. All right, so which is the smallest here? So this is number 1, smallest. Then, am I right? No, I'm not. Okay, because I miss out of the 0 here. All right, so this is number 1. Number 2 is this one. Then number 3 and number 4. Because you can take a look at this. This we can say this is 6, this is 16, this is 26, and this is 60. All right. Then if we take a look at B, similarly we just add a 0 here. So we have 8, 18, 28, and 7.80. Okay, the rest you can try yourself. All right. Then you can see we have the answers here. Okay. Okay, so just now from lowest to highest, now it's highest to lowest, means it's a descending order. So I'm sure you would know. All right, just go to the downwards. Okay. Means 61 is the biggest. Why? Because we take a look at the decimal place. If I look going back here, okay, we want to see, we want them all to have the same amount of decimals after, I mean digits after the decimal. Okay, 2, 2, 2, 2, 2. So 61 is obviously the biggest. Okay, then we have 6.41, 6.4. Now comparing 6.4 and 6.4, which one is bigger? Obviously it's 6.41. Why? Because 41 is bigger than 40, right? And then 6.14 and 6.404. Okay. All right, that's all. Thank you very much.